Hello and welcome. So when we're looking at this, it says for the complex number z, determine the following. Z is negative 7 plus I. Alright, that's our complex number. And then it tells us to find the z with a little bar above it, z times that z bar, and then z that looks like some absolute values. Now, this is kind of confusing. Complex numbers, these don't mean the same thing, like arithmetically is what they would mean, or symbolically, I guess I should say, as what they do mean in other areas of mathematics. When we're talking about anything with this bar, that's a fancy way to say, let me not write that weirdly, conjugate. Okay, that is the same thing as a conjugate. These are not absolute values. That means the modulus. Okay, so how do we find conjugates? Remember, we may have learned this in the past. A conjugate is essentially taking the binomial that you see, and essentially what it does is it flips the sign of the imaginary part. So the conjugate for our adorable z here, right, if we were to find the conjugate of that, it would be negative 7 minus I. And that would be true for any complex number you see. Like, what if we had a complex number of, like, 2 minus 3i? Well, its conjugate would be 2 plus 3i. Right? Let's say that we had 7. What's its conjugate? 7, because that's plus 0i. This would be technically minus 0i, which is still just 0, and it would just not change. Right? What if, this is kind of the weird one, what if we had a conjugate of like a complex number of negative 4i? What would its conjugate be? Plus 4i. Kind of a little weird, because if it's 0 minus 4i, then it becomes 0 plus 4i, the sign would flip. Right? So do keep in mind that's a plus bi format for all of these, and it's always going to be the imaginary part that switches the sign. Right? This will not change. So you'll notice how if we added positive before, it remained positive. If it was negative, it remained negative for the real portion. Okay? But there you go. There's the conjugate. Okay? So that means that negative 7 minus I, conjugate. This just means the product of z, negative 7 plus I, times negative 7 minus I. That's all it's asking for. And then you would just distribute that, negative 7 times negative 7, 49, plus 7i, minus 7i, minus I squared. Now, remember, I squared is a definition that equals negative 1, which means that then you have 49 plus 0i, right, because those cancel out. So I'm going to take that out. And then we have minus, and then that definition, I squared is a negative 1, so then it's minus a negative, which is just a positive, right? That's 49 plus 1, which is 50. Okay, so there's the conjugate times the regular complex number. Now the last thing is the modulus. Right? To see this a little bit better, I'm just going to show you what it looks like. So let's graph this really quick. Negative 7 is over here on the complex number plane. Positive 1, so that means your complex number will be about there-ish. Okay, that means you traveled 7 to go there, and 1 to go there. The modulus is the distance. If you were to finish that off, that's a right triangle, right? If you were to finish that triangle off, the hypotenuse of that triangle is known as the modulus of the complex number. It's the distance from the origin to the complex number itself, right? This is the modulus that you're looking for, which means all we gotta do, that's a right triangle. You know, 2 of the 3 sides. Pythagorean theorem, right? That's legitimately how you find the modulus, is that you take leg squared plus the other leg squared equals your hypotenuse squared, right? And then you would square root the hypotenuse, and that will give you your modulus. Okay, because it's a squared plus b squared equals c squared. A and b are the legs, right? So you would square root, and then your hypotenuse equals the square root of a squared plus b squared. Okay, legitimately, the modulus, the formula, if you were to look it up, would be square root of the real squared plus the imaginary squared. Like, that is always going to be the modulus of any complex number. Okay, and then, so in this case, all we got is 49 plus 1 square rooted equals z, right? And square root 50. Huh, that sounds so familiar. It should be. That's not a coincidence. Okay, you'll notice that the conjugate times the regular complex number and then the modulus of that complex number will be the same number. You'll get 50 both ways. The only difference is that the modulus, square rooted. There you go, there's the difference. Nothing too crazy. Alright, and then last but not least, don't forget to simplify your square roots. That's 2 and 25, 5 and 5. 5 comes out, root 2 remains. And you're done. That is everything there is for complex numbers. Okay, alright. Thank you so much for watching.